Hello all. So welcome back. So this is the second part of NumPy. So in this lecture we'll see how to reshape ndarrays, then also how to index ndarrays, and also how to slice ndarrays. We have already seen slicing in list. So similarly we can slice elements from ndarrays also. So we will see all these things. So first we will see how to reshape ndarrays. So how to change the shape of ndarrays. We can change from one shape to another shape of ndarrays. So first we will create an ndarray. So we will create a two-dimensional array, np.arr. Then we will enter some elements. So the first row will be 2, 3, 4. And second row will be 5, 6, 7, 8. Okay, so this will create a two-dimensional array. If you print this, you can see that it will create a two-dimensional array. Now this is actually the shape. You can check the shape also. The shape a.shape will give the shape. So a shape is 2, 4. Now if you want to change the shape, the total there are 8 elements. So keeping that 8 elements, you can change from one shape to another. So if you want to change the shape from 2, 4 to 4, 2, so it is all possible. So what you have to do is a equal to a dot reshape. So for that we can use reshape function. So and you can simply mention 4, 2. Now if you print this, you can get you will get the reshape thing. So it will contain, it is also two-dimensional, but it contains 4 rows and 2 columns. We have 4 rows and 2 columns. So we can reshape. So we can, if you want, we can reshape it to a 3-dimensional thing also. If you want to reshape it into a dot reshape of 2, 2, 2. So this is also possible because the total number of elements will be 8 itself. 2 into 2 into 2. It is the total elements will be 8 itself. So if you want to reshape, it is also possible. Now if you print this, you can see that it has been reshaped to a three-dimensional array. 3-dimensional array. So we have reshaped the same thing into 3 dimensions. For that we can use this reshape. Now we can, the useful thing in machine learning is we need to flatten some arrays. That is to convert 3-dimensional or 2-dimensional arrays into a 1-dimensional array. Okay, for that, for example, if you want to flatten this, if you want to flatten, so if you want to flatten into a 1-dimensional array, what you have to do is you are declaring a new array and you are going to flatten this A array into a 1-dimensional array. So what you have to do is you have to a dot reshape of, what you have to do give is -1. So you have to simply mention -1. Now if you run this program, now you can check this. Now if you check new array, you can see that it has been flattened to a 1-dimensional array. Okay, so in this way you can flatten into a 1-dimensional array. So for the flattening into 1-dimensional array, you have to simply use reshape of -1. So this is useful in machine learning and all. When you do some, when you want to do some regression analysis or some other analysis, you may have to reshape that multi-dimensional array into a 1-dimensional array so that it will contain only 1 row of values. So this is not a flattening of array. So for that, what you have to do is you can simply use this reshape of -1. Now I'll show another example. I'm creating another array, AR dot, using that ARrange function. We have already seen ARrange function, and I'm giving it as ARRNP. Now I have created an array. Alt enter. Okay, sorry. a range, ARR equal to np dot arrange. Okay. Now if you print this thing, you can get an array of 15 elements. So it will be a one-dimensional array. Now if you want, you can reshape it into anything. So if you want to reshape into shape, ARR reshape of it is 15 elements, so you can reshape to 3, 5. So it will be 3 into 5, it is 15 elements. So it is also possible. So now it has been reshaped into this thing. So one thing here to note is I have not assigned this to anything. Now if you again print this ARR, you won't get this array. So you will get only this one-dimensional array. So this means when you are doing this reshape, this is actually only a view of that array. So if you want to change it permanently, what you have to do is when you do this operation, you have to store it somewhere. So you have to make it, you have to assign that value to somewhere. Then only it will change it. Now if you check ARR, it will be that 3, 5 array. So that is the thing you have to note. So if when you are doing this operation, it actually gives only the view of that array. So if you want to make it permanently, you have to assign it to some variable. Then only you will get that. That change will be reflected in the 3-dimensional array. So that's all about reshaping. Then there's another operation in this thing in this NumPy, that is transpose, to find the transpose. So what you have to do is you have to simply mention arr.t. So if you mention arr.t, you will get the transpose of that matrix. So this is the transpose of this matrix. So it is 0, 5, 10, 1, 6, 11, 2, 7, 12, like that it will go on. So you have to simply mention that array dot transpose. So you will get the transpose of that matrix or transpose of that ND array. Okay. Now, if you want, this is useful when you do matrix computations and all. You may have to find the inner matrix product or dot product. So if you want to find the inner matrix product or dot product, you can simply use the function np dot. So this is a function to find the dot product, and the parameters for that dot function is np dot. It is actually the transpose of that matrix multiplied by that matrix. So this is actually the array, transpose of that array multiplied by that array. You will get the dot product. So if you want to, so this is the dot product of ARR dot T into ARR. So that gives a transpose. So this is useful in matrix computation. So you can use this dot function to find the dot product. This is shown an example. Okay. Now we will see for higher dimensional arrays. So for higher dimensional arrays, you can simply do this transpose. I'll show an example. Now I'll create another 3-dimensional array. So np.arrange can be used to create this thing. So I want to create a 16 element matrix, 16 element n-dimensional array, and I am using this reshape. I can reshape here itself. So if I give np.arrange of 16, you will get a 1-dimensional array of 16 elements. That is 0 to 15. You will get 0 to 15. You will get 16 elements, a single row array. Now, if you specify the shape here itself, you will get the shape. So I am specifying the shape as 2, 2, 4. So this is 2 into 2, 4, 4 into 4, 16. Now if you print this, you can see that so you will get the array. So it is shape. The shape of this is 2, 2, 4. Now, if you want to find the transpose of this thing, you can change this. If you want to find the transpose and assigning it to some value, transpose there is another function called transpose. And here you can specify the axis change. So what I am doing is I am specifying the axis here. So what I have done is I have kept the second axis at there itself, and I have changed 0 and 1. So in the place of 0 I have put 1, and in the place of 1 I have put 0. So I have just used the axis numbers. Using axis numbers also I can do the transpose. Now if you print ARR2, you will get the transpose of this matrix. So this is the transpose. This is the transpose of this matrix. So that is also possible. So for that you can use this transpose, and you have to specify the axis numbers, which all axes should be permuted. So I am permuting 190, and I am keeping 2 as such. So you will get the transpose like this. Okay, and you again, if you want, you can do the transpose of the string. It is possible to do using that function. Then if you again do this transpose, you will get another value like this. Everything will be transposed. Okay, so this is the first axis, this is 0th row, and this is first row. Now it will be rotated. So 0, 4 will come like this, then 8, 12 will come like that. It will be changing. So that's all about transpose. Next, we will see slicing. So in list we have seen slicing. So here also we can perform slicing. So slicing means extracting particular element or a set of elements from an array. So if you want to extract a particular element or a particular set of elements, if you want to extract a particular set of elements from an array, then that process is known as slicing. Okay. Now we will use an array that is already there. Okay, I'll create one-dimensional array. So I think we have already created a one-dimensional array here. I will take that same thing here. Okay, now ARR is a one-dimensional array. Now you can do this operation. So if you want to get 0th element, ARR of 0 means it is the first element. Then ARR of 3, any of the elements you can get simply by giving this. So this is the way you can index it. So you'll get the third element. And if you want to, if you give ARR of minus 1, that you have already seen, sorry, minus 1. So we have already seen in list also, if you specify minus 1, then the last element will be returned. So the last element will be returned. So this will be the 14 will be returned. Then you can perform slicing like in list. If it is one-dimensional, like in list, you can specify 1 to 4. So you are specifying 1 to 4. So you can slice like 1 to 4 means this is 0, this is 1. So 1, 2, 3, and this is 4th element. So excluding 4th element. So only these 3 elements, 1, 2, 3 will be returned. So if you run this thing, you can see that it will return 1, 2, 3. So it will be returning an array itself. It will be returning an array itself with 3 elements. Then we have already seen in list also, if we are using something like 1 colon, we are not specifying the last thing, or if we are simply mentioning 3 colon, we are not specifying the last element. So what you will get is it will start from the third element. So 0, 1, 2, and this is the third element, 3. So it will start from 3 to the last element, 3 to 14. So it will return the whole element. So in this way you can slice. So we have already seen this slicing in list also. So we already see. So actually slicing gives only the view. So it is actually the view of that thing. I will show that thing. So I am going to slice and I am going to store it in a variable arr.slice. I am storing arr of 1 to 5. So I am going to slice 1 to 5. That means from here to, so this is 1, this is 2, 3, and this is 4, and this is 5. So excluding 5. So only these 4 elements will be sliced. Now if I run this, you can see that. Now if I print this, it will be ARR slice. So the slice is 1, 2, 3, 4. Now the interesting thing to note is, if I am going to change, now you know ARR of slice of 0. So if you check ARR of slice of 0 is, actually it will be 1. So this will be 1. You know, you can index this first element using 0. Now what I am going to do is I am going to change ARR of slice of 0 to some other value. I am giving as 1000. Okay. Okay. So I have assigned 1000 to ARR slice of 0. Now what I am going to do is I am going to check the value or the array in ARR. Now if you check ARR, the value of first element is changed to 1000 here also. So this is what it happens. So both will be pointing to the same location. So you see that now ARR is actually this complete array. Now what I have done is I have sliced that array and I have stored only the 4 elements I have taken and I have stored it in ARR slice. So this is ARR slice. Now what I am doing is I am changing the 0th element of ARR slice. So that's what that's what I am doing here. I have changed to 1000. So actually this change is reflected in this array also. It is reflected in ARR also. So this 1 is changed to 1000. So that is what happens. So both are pointing to the same location. So even if you are sliced, that change will be there also. The slice in that slice also, that change is there. So the change happens in both the array and also the slice of that array. Okay. Now we will check for higher dimensions. Now we will create higher dimensional arrays. This is actually one dimensional array. Now how to index higher dimensional arrays? Now we will create another higher dimensional array. That is, we will create a 2-dimensional array. I am naming it as ARR2D. Now I will use the same range function, or you can I will use the range function here. That will be better. So I will be creating 10 element array. Okay. NP dot 9 element. I want only up to 0 to 0, 1, 2, 3, 4 up to 9. Then I'll be shaping. I'll be shaping it to. I'll shape it to. Okay, I'll use it 8 elements. Then I'll reshape it to 4, 2. Let it be 4, 2. Now ARR 2D will be like this. Now, if you want to get some elements, so we will check indexing in this thing. So if you give ARR 2D of 2, so what will be the output? So ARR of 0, 2D of 0 is this line. This is 1. This is 2. So if we give 2, then we will get the second. The 4, 5 will be returned. Okay. Now if you want to get an individual element, so what you have to do is you can either do this way. So from the 0th row, and you want the first element 0, 1. So if you give this, you will get this first element 0, 1. Now, another way to do the same thing is you can ARR of 2D, and inside square bracket you can simply specify 0, 0, 1. Then also you will get the same one. So both ways you can index a particular element in two-dimensional array. So you can create a two-dimensional array in this manner. Okay. So and you can index using individual elements, or each row can be indexed like this. So 2 gives the second row, that is third row, 0, 1, and this is 2. So this is the 3. So if we give 3, then third row will be indexed. So, and also for indexing particular element, you can use either this notation or this notation. In this way, you can index two-dimensional. Now we will check for another 2 by 2 by 3 matrix. So it should contain 7 elements. So I'll create a 3D array. ARR 3D equal to np dot array. Now I'll create a 3-dimensional. So it should have 1, 2, 3. Then another one 4, 5, 6. So this is 4, 5, 6. Then I'll close this one. This is the first row. So I'll close this one. Then after that 7, 8, 9. I'll open another one. 7, 8, 9. I'll close it. Again comma. I'll open another one. 10, 11, 12. And I'll close the whole thing. I think it's correct. Okay. So 7, 8. Let me check. So 1, 2, 3. So 1, 2, 3. All the first 3. 1, 2, 3. Then 4, 5, 6. I'll close that to 1. I'll put a comma here. Then I have to open this again. 7, 8, 9, 10, 11. And I have to close one more braces. Okay. Now, if you check, this is the 3-dimensional array. So this is actually a 3-dimensional array. So this is the 3-dimensional array. Now, how to index this 3-dimensional array? We'll see different examples for this indexing. Now, if you want to index this 3-dimensional array, if you give a 0, ARR 3D of 0, what will be the output? So you'll get the 0th element. So this is the 0th row. So you will get the first 0th axis. So it will be all these elements. And this is actually, so I have created actually 2 by 2 by 3 array. 2 by 2 by 3 array. So this is 0, this is 1, like that it will go on. Then inside that it will be 0 and 1, like that it will go on. Then this is the column. So it is actually 2 by 2 by 3 array. 2 by 2 by 3 array. So if you AR of 3D of 0 gives the first 0th row. This is actually the 0th row. Then if you want, now if you want, I'll create one more array, or we will use the same array. So I'll create a large 3-dimensional array, AR of 3D, using the np.reshape of 24. So 24 element array, and I am specifying, and I am specifying the shape also, reshape. I have to reshape it to 3, 4, 2. So 3, 4 is 12, 12 into 2, 24. Okay. Now I will print that ARR 3D. Now if you print that, you can see that this is the array that I have printed. So this is the actual array. So these are the elements of that thing. 0, 1, like that. It has been arranged like this. So it is 3, 3. So this is 0, this is 1, and this is 2. Then there are 4 in each column. So this is 4, and after that in the third axis there are 2 elements. So it is like this, it will come. Now if you want the 0th element, you can 3D of 0 gives a 0. So all these elements will be returned. Now if you print this, so all these elements will be printed. Then another thing to note is both scalar values and array can be assigned to this array. So if a 3-dimensional array is used, if we want to assign some values, so we have already seen how to index. Now if you want to assign some values, we can assign scalar values. That is ordinary term value like 25 can be assigned to the set of values. And also if you want to assign an array to this, it is also possible. For that I will show that an example. Now what I am doing is I am going to copy this. So we have already found out ARR 3D of 0. So I am copying it to another array. So I am copying this element to another array. So old is actually this thing. Okay. For copying, if you want to have a separate copy, then what you have to do is you can use this copy function. Then it will be, we will have a separate copy of that. It won't be the original thing. So it is for this example, I am creating another copy of this array. So otherwise, we have already seen in the previous example, we have seen if we make any changes to this array, it will be reflected in the original array. So if you are making this using this copy function, then it will create another copy of this array. Okay. So I'll delete this thing. Okay. Now I have made the copy of this thing. So for that I am using a copy function. Now if you check old, it will contain this array, and ARR 3D will be like this, and ARR 3D will be like this. So I have just made a copy of that array. Now what I am going to do is I am changing the value of ARR 3D of 0. I am changing the value to 25. So this is a scalar value, and I am assigning the scalar value to ARR 3D of 0. So ARR 3D of 0 means all these elements. So all these elements value will be changed to 25. Okay. So all these values will be changed to 25. Now if you print this thing, you can see that all the value of the 0th element has been changed to 25. For that I have simply assigned a scalar value. So this is actually assigning a scalar value to an array. So we are assigning a scalar value to an array. Now we can assign an array also. Now if we want to restore the previous value. So the previous value is actually 0, 1, 2, 3, 4, 5, 6, 7. So if you want to assign 0, 1, 2, 3, 4 to the whole ARD of 3 of 0, it is also possible because we have already stored it in old. So old contains the previous value. Now we can assign an array to an array. So for that, what you have to do is we have to assign 0, means the 0th elements. So all the 25 elements, we want to change it to old. Now if you print this ARR of 3D, you can see that the values has been restored. So what we have done is, initially in the first step what we have done is we have assigned a scalar value to ARR 3D of 0. That means the whole array, all these 8 values have been changed to 25. Now we are changing the whole 25, all the 8 values to a single value using an array. So we are assigning an array to that array. So that's also possible in the 3-dimensional array. Okay. Now if we want to index a particular element. Now, if we want to index a particular element, like in two-dimensional array, we can index a particular element also. So, if we want to index ARR 3D of 1, comma 0. So, we'll check what will be the output. Now, if we check, it will be 8, 9. So, it will be 8, 9. So, 1, comma 0 means, so this is 0 and these elements will be 1. And if you are giving 1, comma 0, it will be this 8, 9. And if you want to get this 9, then what you have to do is ARR of 3D, comma, so this will be 0, 1. So it will be 1. So you'll get 9. So like this you can index. And the same thing. So we have already seen this thing. This can be done in 2 steps also. You can do this in 2 steps also. So for that, what you have to do is I am assigning this value to, I am first getting this ARR 3D, ARR 3D of 1. So this means the first rows. So all these elements we will get, and I am assigning to X. Okay. So X will be, now if you print X, you can see all the elements. Now if what I want the 8, 9, the first row I want. For that, what you have to do is, what you have to do is X of 0. So it will return the first row. So this is 2-step indexing. So this is also possible. Now what I have done is I assigned this to another variable X, and I have taken the 0th element from that array. So that is also, this is known as 2-step indexing. So anyway, you can index any of these elements. Now next we will see indexing with slices. So ndarrays, this n-dimensional arrays can be sliced also through indexing also. Now for that we will create an array. So we'll create an array ARR equal to np dot a range of 10 elements. Anyway, let it be like this. Now if you print this, you can see it is contains these elements, and we have already seen this slicing. So for that 1 to 6. So in this way you can slice. We have already seen this. So all the from 1 to 6, excluding 6. So 1 is this one, 2, 3, 4, 5, and this is 6. So we have to avoid this, and up to 5 only we have to print this. And the same thing we can do in 2D also. np dot a range of, I am using 9, and I am going to reshape to let it be 3, 3. (2D) of 2. So what it will give? So if you are mentioning AR of 2D colon 2, so output will be like this. So only the first 2 rows will be displayed. So this means, so all the rows up to 2, that means 0th row and first row will be written except 2. So whatever we have done here, same like this. In the case of one-dimensional array, if we are giving 1 to 6, except 6 up to 5. So if you are specifying up to 2, it's like specifying 0 to 2. Same output. So if you are not specifying the first element also, it means that it contains all elements up to 2 except that second row. So this is 0 and this is 1. So only those two will be returned. And also we can perform multiple slices also. Like you pass multiple indexes, here multiple slicing is also possible. For that, ARR of 2D of, I'm giving slice column. Like this, you can do multiple slices also. Now we will see the output. So you can see that the output is 0 and 3. So the output is 0 and 3. So what you have done is, from this array, this is up to 2. So this means up to only these 2 columns will be taken. So this is array, only these 2 rows will be taken. This 2 won't be taken. And this means up to 1. So that means only up to 1. So 0th column and first column, and only 0 and 1 column will be taken. So 0 and 3 will be returned. So in this way we can do this thing. All the elements will be of same dimension. Now if you want to perform, if you want to change the dimension also, it is possible using this slicing. ARR of 2D of 1 comma. So we will be specifying 1 comma, and you will be specifying the second index. Okay, before that, I'll just print that ARR of 2D, then it will be better. So now I am doing the same thing here. So output will be 3, 4. So how you got this? Now what I have mentioned is ARR of 1. So what you have to take? You have to take the first row. So this is 0th row, and you have to take first row. And from first row, what you have to take? You have to take only up to second element. That is excluding second element. So this is 0th element, and 1, this is 2. So we should exclude this 5. So you will get 3 and 4. Similarly, you can perform ARR of 2D of colon 2, comma 2. So you will get 2 and 5. So this means you have to take 0 to 2 rows. That is, you have to take the first 2 rows, and from first 2 rows, what you have to do, you have to take only the second column. So that means this is 0, this is 1, and this is 2. So you will get 2 and 5. So it will be one-dimensional array. So it will be returning a one-dimensional array. So this way you can slice. Then again we will do another example, ARR of 2D, and I am specifying column. Simply I am specifying column and column 1. Now you will get another array. So column means, so if you are specifying column means the whole elements will be taken. Now in the second slice, what I am mentioning, only up to 1. Only up to 1 means you have to take only the 0th column. That is 0, 3, 6 should be returned. Okay. Then it is also possible to slice and assign values also. So for that, if you want to assign, so we have already taken this thing, to slice comma 2 comma 1 comma equal to, if you want to assign 0 to some of the values. Okay. Now if you print this ARR 2D, you can see this. So these 4 values have been changed. This is 0, 0, and this 0, 0 has been changed. So this is done using this value. So we can slice and assign values also. So this means you have to take up to 2. So 0, 1, and 2. So this is 0, this is 1, and this is 2. Then after that, what I have mentioned, you have to 1, and you have to change the first value to 0. So that's what we are doing here. Okay. So in this way you can slice also, slice and assign values. So I'll show an example of slicing. So these are the various slices we have done. So this is the expression. ARR of slice 2 means you will be taking up to 2 comma and 1 2 2. So it will be a 2 by 2 shape. the shape of will be 2 comma 2. So these are the elements that will be sliced. Now ARR of 2 means it will be this row. ARR of 2 comma column also means this row. And the shape of that return shape will be 3 comma 0. It will be a one dimensional. Then if you are specifying like ARR 2 colon comma colon, it will be also the same element, but the shape will be 1 comma 3. That is 1 row and 3 elements. So it is 2 dimensional. These two are one dimensional arrays. Now this is another example for the same thing. ARR colon comma colon 2. So it means all these elements. Colon means all the elements, and up to 2 only means only these 2 will be taken. And from that, what you have mentioned, the shape will be 3 comma 2. So 3 rows and 2 columns. Now if you specify this ARR 1 comma colon 2. So ARR 1 means this row, and colon 2 means up to this except 2. So all these 2 elements. So it will be a one dimensional array. Then do the same thing, ARR 1 to 2. So that means 1 to 2 means only the first row. The one row will be taken, row 1 will be taken, and up to 2 elements. So excluding the second element. So 0 and 1 will be taken. So the elements output will be 1 comma 2. So it is a 2 dimensional array. So based on the slicing and indexing, we can change the shape of the array. So if we want to change reshape, it will be a one dimensional array. So these are all actually 3 dimensional, and we are reshaping into a one dimensional array. One dimensional array containing 3 elements. So it is also possible by using the slicing and indexing operations. So these will be required when you do this machine learning things. So that's all about NumPy slicing and all. Thank you.